If you require the assistance of an electrical engineer with expertise in arc blast incidents for litigation purposes, a valuable resource is the International Brotherhood of Electrical Workers. Their website, www.ibu.org, serves as a portal to locate qualified engineers in your specific geographic region. Utilizing their website could greatly improve your chances of finding a suitable professional to assist with your litigation needs. Arc blasts are extremely dangerous events that occur when electrical current flows through an unintended path, such as air. This can be caused by a variety of factors including insulation failure, accidental contact with energized components, or equipment malfunction. The consequences of an arc blast can be severe, resulting in serious burns, injuries, and even fatalities. Understanding the physics behind an arc blast is crucial for engineers investigating such incidents. The process begins with an electrical fault, which creates a low impedance path for current flow. This sudden surge of current causes rapid heating of the air and surrounding materials, leading to the formation of a plasma. The plasma is an extremely hot and ionized gas that conducts electricity very efficiently, sustaining the arc. The temperature of the arc can reach tens of thousands of degrees Fahrenheit, far exceeding the melting point of most metals. This intense heat causes rapid expansion of the air, generating a powerful pressure wave known as an arc blast. The arc blast can propel molten metal and debris at high speeds, causing significant damage and injury. Additionally, the intense heat and ultraviolet radiation produced by the arc can cause severe burns to anyone in close proximity. Several factors influence the severity of an arc blast, including the voltage and current levels, the duration of the arc, and the distance from the arc. Higher voltage and current levels result in more energy being released in the arc, leading to a more powerful blast. The longer the arc duration, the greater the total energy released, and the more severe the consequences. The distance from the arc is also a critical factor, as the intensity of the heat, pressure wave, and radiation decreases with distance. To mitigate the risks associated with arc blasts, it's essential to implement appropriate safety measures. Firstly, proper installation and maintenance of electrical equipment are crucial to prevent faults from occurring. Regularly inspecting and testing equipment can help identify potential problems before they lead to an arc blast. Secondly, using personal protective equipment, or PPE, is essential for workers who may be exposed to arc flash hazards. PPE includes flame-resistant clothing, gloves, face shields, and helmets that are designed to protect against the intense heat, pressure wave, and radiation produced by an arc blast. Thirdly, implementing arc flash protection devices can help reduce the duration and severity of an arc blast. These devices include current-limiting fuses, circuit breakers with fast tripping characteristics, and arc flash relays that detect the presence of an arc and quickly trip the circuit. Engineers investigating arc blast incidents typically follow a systematic approach to determine the cause and contributing factors. Firstly, they gather information about the incident, including the date, time, location, and circumstances. Secondly, they inspect the equipment involved in the incident, looking for signs of damage, insulation failure, or other abnormalities. Thirdly, they analyze the electrical system to determine the voltage, current, and fault levels. Fourthly, they review any available documentation, such as equipment manuals, maintenance records, and electrical diagrams. Fifthly, they may conduct interviews with witnesses and personnel involved in the incident. Finally, they prepare a report summarizing their findings and recommendations. The report typically includes a detailed description of the incident, an analysis of the cause and contributing factors, and recommendations for preventing similar incidents in the future. The report may also include calculations of the arc flash hazard levels, which are used to determine the appropriate PPE requirements. Electrical engineers use several key tools and techniques when analyzing arc blast incidents. Firstly, they use multimeters to measure voltage, current, and resistance in electrical circuits. Multimeters are essential for verifying the condition of equipment and identifying potential faults. Secondly, they use oscilloscopes to analyze waveforms and transient events in electrical circuits. Oscilloscopes can help identify the cause of an arc blast by capturing the voltage and current waveforms during the incident. Thirdly, they use infrared cameras to detect hotspots and thermal anomalies in electrical equipment. Infrared cameras can help identify potential insulation failures or loose connections that could lead to an arc blast. Fourthly, they use computer simulation software to model the electrical system and simulate arc blast scenarios. Computer simulations can help engineers understand the behavior of the electrical system during an arc blast and evaluate the effectiveness of different protection strategies. The NEC, or National Electrical Code, provides guidance on electrical safety requirements, including arc flash protection. NEC Section 110.16 requires that electrical equipment be marked with a warning label indicating the arc flash hazard levels. The label must include information such as the incident energy, the working distance, and the required PP. NEC Section 240.87 provides requirements for arc energy reduction, which aims to reduce the duration and severity of arc blasts by using current-limiting fuses, circuit breakers with fast tripping characteristics, or arc flash relays. NEC Section 70E provides comprehensive guidance on electrical safety in the workplace, including requirements for arc flash hazard assessment, PPE selection, and training. A qualified electrical engineer involved in arc blast litigation needs a comprehensive understanding of electrical power systems, protection principles, and safety standards. Firstly, they must have a strong foundation in electrical engineering fundamentals, including circuit analysis, power system analysis, and electromagnetic theory. Secondly, they must have a thorough understanding of arc flash phenomena, including the physics of arc blasts, the factors that influence their severity, and the methods for mitigating their risks. Thirdly, they must be familiar with relevant industry standards such as the NEC IE 1584 and NFPA 70. Fourthly, they must have experience in conducting arc flash hazard assessments and developing arc flash protection plans. Fifthly, they must have excellent communication skills to effectively explain technical concepts to non-technical audiences such as lawyers, judges, and jurors. Several organizations offer certifications for electrical engineers specializing in arc flash safety. The IE offers the Certified Electrical Safety Technician or CEST certification, which validates an individual's knowledge and skills in electrical safety practices. The NFPA offers the Certified Electrical Safety Compliance Professional or CESC certification, which recognizes individuals who have demonstrated expertise in electrical safety compliance. The Association of Energy Engineers, or E, offers the Certified Energy Manager or CERM certification, which covers a range of energy-related topics, including electrical safety. Furthermore, the practical application of engineering principles is paramount when investigating arc blast incidents. This involves a detailed examination of the electrical system's design, installation, and maintenance records. An engineer will meticulously review schematics, protective device settings, and grounding configurations to identify any deviations from industry standards or manufacturer specifications. For example, an improperly grounded system can significantly increase the risk of an arc flash, as it may not provide a low impedance path for fault current to flow, delaying the operation of protective devices. Similarly, incorrect settings on circuit breakers or relays can lead to prolonged fault clearing times, resulting in higher incident energy levels and more severe arc blasts. The engineer would also assess the coordination between different protective devices in the system. Ideally, protective devices should be coordinated such that the device closest to the fault trips first, minimizing the impact on the rest of the system. However, if the coordination is poor, a device further upstream may trip unnecessarily, causing a wider outage and potentially increasing the arc flash hazard. Another critical aspect of the investigation is to evaluate the human factors involved in the incident. This includes assessing the training and qualifications of the personnel who were working on or near the equipment at the time of the arc blast. Were they properly trained in arc flash safety procedures? Were they wearing the appropriate PPE? Were they following established work practices? Human error is often a contributing factor in arc blast incidents, and understanding the role of human factors is essential for developing effective prevention strategies. In addition to the technical aspects of the investigation, an engineer involved in arc blast litigation must also possess strong analytical and problem-solving skills. They must be able to gather and analyze complex data, identify patterns and trends, and draw logical conclusions. They must also be able to communicate their findings clearly and concisely, both in writing and verbally. This may involve preparing expert witness reports, providing testimony in court, and explaining technical concepts to non-technical audiences. Furthermore, the engineer must remain objective and unbiased throughout the investigation. Their role is to determine the facts of the case and provide an independent assessment of the cause and contributing factors of the arc blast. They must not be influenced by external pressures or conflicts of interest. Arc flash incidents can have devastating consequences, and it is crucial to conduct a thorough and impartial investigation to prevent similar incidents from occurring in the future. The goal of arc flash mitigation is to reduce the likelihood and severity of arc flash events, protecting personnel and equipment. This can be achieved through a combination of design, maintenance, and operational practices. One of the most effective mitigation strategies is to reduce the voltage and current levels in the electrical system. This can be achieved through the use of transformers, current-limiting reactors, and other devices. By reducing the energy available in the system, the potential for a severe arc flash is also reduced. Another important strategy is to improve the design of the electrical system to minimize the likelihood of faults. This includes using high-quality insulation, providing adequate clearances between conductors, and implementing robust grounding systems. Proper design can help prevent faults from occurring in the first place, reducing the risk of arc flash events. Regular maintenance of electrical equipment is also essential for arc flash mitigation. This includes inspecting equipment for signs of damage, cleaning equipment to remove dust and debris, and testing equipment to ensure that it is functioning properly. Regular maintenance can help identify potential problems before they lead to an arc flash. Operational practices also play a crucial role in arc flash mitigation. This includes following safe work practices, using appropriate PPE, and implementing lockout/tagout procedures. Safe work practices can help prevent accidental contact with energized equipment, reducing the risk of arc flash events. Appropriate PPE can protect workers from the hazards of an arc flash, such as burns and electric shock. Lockout/tagout procedures can ensure that equipment is de-energized before work is performed on it, preventing accidental energization and arc flash events. Finally, the selection of appropriate protective devices is critical for arc flash mitigation. Protective devices, such as circuit breakers and fuses, are designed to interrupt fault currents quickly, limiting the duration and severity of an arc flash. The selection of protective devices should be based on a thorough arc flash hazard assessment, which takes into account the voltage, current, and fault levels in the electrical system. An arc flash hazard assessment is a systematic process for evaluating the potential for arc flash events in an electrical system. The assessment involves identifying potential arc flash sources, calculating the incident energy levels, and determining the appropriate PPE requirements. The results of the assessment are then used to develop an arc flash protection plan, which outlines the steps that will be taken to mitigate the risks of arc flash events. The assessment typically involves several steps, including gathering information about the electrical system, performing calculations to determine the incident energy levels, and evaluating the potential for human error. The information gathering process includes reviewing electrical diagrams, equipment manuals, and maintenance records. The calculations are performed using specialized software or hand calculations based on industry standards. The evaluation of human error involves considering factors such as training, experience, and work practices. Once the assessment is complete, the results are used to develop an arc flash protection plan. The plan should include specific recommendations for mitigating the risks of arc flash events, such as the use of appropriate PPE, the implementation of safe work practices, and the installation of arc flash protection devices. In summary, securing the services of a proficient electrical engineer, especially one recommended by the International Brotherhood of Electrical Workers, is a strategic step when facing litigation related to arc blast incidents. Their expertise in electrical systems, safety standards, and investigative techniques is invaluable in determining the cause, impact, and preventative measures associated with such events.